So we're going to go over the homework from, excuse me, from last week. I am on page 375, numbers 11 and 12 in the textbook. All right, so we're starting with 1.50 moles of S8. And of course, well, before we start that, let's review the steps for all stoichiometry problems, okay? Step 1 is balance. Step 2 is start with what you're given. Pretty straightforward, pretty easy, right? Step 3, you're going to change that to moles. If it's already in moles, check, you're done with that one, right? Then you're going to write your mole to mole ratio, which this means the moles you're going to goes on top, the moles you're going from goes on the bottom, okay? Then you're going to change it to the unknown unit, meaning change it to what you're looking for, okay? All right, so back to that one. So we start off, well, first we have to balance the equation, okay? So we balance that, we have our coefficients of 2, 1, 2, and 4, okay? So we start off with our 1.50 moles of S8. It's already in moles, so we're done with that one. We're going to write our mole to mole ratio. Don't forget, these coefficients come, or these numbers come from the coefficients in our balanced equation, okay? Excuse me. And so we write our mole to mole ratio, do the math, and we end up with 3.00 moles of CS2. The reason we're done after that is because they were asking us how many moles of CS2. So we're done there. All right. We're going to do a very similar process in part C. I'll give you a minute to look over that. So we start with 1.50 moles of S8. We're looking for the number of moles of H2S, so this other product, okay? So we don't have to change it to moles because it's already in moles. We write our mole to mole ratio, do the math, and we end up with 6.00 moles of H2S. Number 12. We write our balanced equation, okay? There's that. Here we're starting off with 12.5 moles of SO2, where we don't have to change that to moles because it's already in moles. We write our mole to mole ratio. Again, these numbers come from the coefficients in our balanced equation, which is why that is so super critical that you have to balance the equation first. Otherwise, these numbers of your mole to mole ratio are going to be incorrect. Okay? Yeah, drink water. Well, so we write our mole to mole ratio. And then we do the math. Again, 2 over 2, that's just 1, okay? And then, so you end up with the same amount of moles that you started with, okay? So 12.5 moles of H2S. All right, so here we have 12.5 moles of SO2. We don't have to change it to moles, it's already in moles. We write our mole to mole ratio. We're going to moles of O2 this time though. So we're looking for the one of the other reactants, okay? So we write our mole to mole ratio. These numbers come from the coefficients in our balanced equation. Okay, so we have a 1 here and a 2 here. 12.5 times 1 divided by 2 is 6.25 moles of O2. All right. I will post these. I will scan these and post these too, so you'll have those. Number 13. All right. I'll give you a second to look over those. Okay. Write your balanced equation. We start off with 2.50 moles of sodium chloride. Write your mole to mole ratio. We don't have to change it to moles because it's already in moles. Write your mole to mole ratio. Moles of what you're going to goes on top. Moles of what you're going from goes on the bottom. Then we're going to change it to, forgot my multiplication sign. We're going to change it to grams of chlorine. Okay, chlorine's diatomic, so of course we have to have 2 of those. Do the math. 2.50 divided by 2 times 70.90. We want 3 sig figs. We end up with 88.6 grams of Cl2 chlorine. Okay? All right. Moving on to 14. All right. So Write your balanced equation. We start off with 1.25 moles of TiO2, titanium oxide. Okay. Write your mole to mole ratio. These numbers come from the coefficients in our balanced equation. Okay. And then we're going to change it to grams of chlorine because that's what they're asking us for in the problem. Okay, it said how many grams, how much chlorine gas in grams is obtained. Okay, so we want to change that to grams. Okay, because again, don't forget these steps. We're going to balance. We're going to start with what we're given. We're going to change it to moles. We're going to write the mole to mole ratio, which means moles of what we're going to goes on top, moles of what we're going from goes on the bottom. We're going to change it to the unknown unit. Okay? All right. Do the math. We end up with 177. It was not an even number, but we only want 3 sig figs. So we round that to the proper sig figs, which is 177 grams of chlorine. Okay? Chlorine's diatomic, so don't forget that Cl2. Okay. All right. Actually, I'm going to leave that down so you can see that balanced equation. Okay, so now we're looking for grams of carbon. 1.25 moles of TiO2. Still have that same amount of titanium oxide. So we're going to change that to moles of carbon, okay, since that's what we're looking for here. These numbers come from the coefficients in our balanced equation, and we're going to change it to grams of carbon. So now we do the math, 1.25. You don't have to worry about this one because it's times 1 divided by 1 times 12.01. Okay. We end up with 15.0 grams of carbon, excuse me. Okay. Now, C. I want to point out something with C. Part C said, what is the mass of all the products formed? Okay. So part C is asking you, what are the mass of these two products? Okay. Well, you know my motto, work smarter, not harder, right? So we already have the mass of one of our reactants, right? We know that there's 177 grams of chlorine, right? We also know that there are 15.0 grams of carbon. Okay, so that's the other one. We know that there are 1.25 moles of titanium oxide. Isn't it simpler, and doesn't it make more sense, to change our moles of TiO2 to grams and then add up all of those things? Because the mass of your 3 reactants is going to equal the mass of your 2 products. Okay? So that's what I did here. Now, the other option is you can change this. You can take this and you can calculate your number of grams of this one. And you can take this and you can calculate the number of grams of carbon dioxide. But that's doing 2 stoichiometry problems. I've already done 2, and this was a real simple mole to mass problem. So I took 1.25 moles of TiO2, change that to grams. This is my molar mass on top. I get 99.9 grams of TiO2. I add up my titanium oxide, my carbon, and my chlorine, and I end up with 291.9. I only want 3 sig figs because that's what I was working with the entire problem. And I get 292 grams. And again, I wrote here because the mass of the reactants equals the mass of the products, I can do it that way. Okay? All right. So that's 14. Okay, number 15. These are our first mass-to-mass problems that we do. So there's 2 of these. Okay? We write our balanced equation. Actually, they might have given us this. Yes, they already balanced that for us. So we just rewrite that. Okay? We start with 100.0 grams of NaN3. Okay, we're going to change that to moles because, again, our steps. Balance, start with your given, change it to moles, mole-to-mole ratio, change it to the unknown unit, meaning what you're looking for. Okay? All right. So we balance our equation, start with what you're given, change it to moles. We change it to moles by putting the grams on the bottom because that's what we're going from. We're going 2 moles, moles of NaN3. Okay? Write your mole-to-mole ratio. These numbers come from the coefficient in our balanced equation. So we have a 2 on the bottom with our NaN3 and a 3 on top with our nitrogen. And we change it to what we're looking for, which is what grams at N2. All right? Do the math. 100 divided by 6502 times 3 divided by 2 times 28.02. We end up with 64.64 grams of N2, rounding that to 4 significant figures. All right, last but not least. Here's your balanced equation that was given to you. 2.50 grams of SO2. We're going to change that to moles. Write your mole-to-mole ratio. Change that to what you're looking for, which is grams of sulfuric acid. And we do the math. 2.50 divided by 6406 times 2 divided by 2. This is just like saying times 1. Okay. Times 98.08. End up with 3.83 grams of H2SO4, sulfuric acid. Okay. All right. Alrighty, I think we're good. I will go ahead and I will scan these as well as your steps. If you have any questions, you know how to reach me. Please continue working on the worksheets that I posted yesterday.